Hi, my name is Lauren Bauer and I'm participating in Challenge 2014. So in this video, I solve a related rates problem using differentiation of the spherical volume formula, and I hope that this video just gives you a process in order to solve related rates problems.
Okay, so this is a breakdown of how to tackle question number 2 in Math 1000. This related rates question starts with the volume V of a sphere of radius r is given by the formula V equals 4/3 pi r cubed. A spherical balloon is being pumped by an incompressible gas at a rate of 25 cubic inches per second. How fast is the radius of the balloon changing when r is 18 inches? Okay, so after reading all of that, we need to figure out what our unknown is. And in this case, it is the rate of change of the radius when r is 18. Automatically, the phrase rate of change equals slope in my mind. And because this is calculus, we know that slope directly correlates with derivative. Therefore, in this problem, we are looking for the unknown r prime of t. Now that we know what we are looking for, let's go back into the question and pick out the important information. So first, the volume of a sphere is given to us, the formula for that. Second, we're given the rate in which the volume is increasing, so 25 cubic inches per second is going to be our V prime of t. Again, rate is the key word we're using here. And lastly, that r is equal to 18 inches. So right here is the last given. At this point, we have completely broken down the question, but it could still be difficult to just pick out the information from the word. So for people like me, a picture helps a lot. Okay. So with this picture, we know that the volume of the spherical balloon equals 4/3 pi r cubed. And these arrows represent the V prime of t, or the rate in which the volume is increasing, which is at 25 cubic inches per second. And lastly, I'm just going to label the radius here is 18 inches. So from that picture, and knowing that we're looking for r prime of t, we can easily write the equation, solve the problem, and understand what's actually happening. With the given formula, I'm going to write here, V equals 4/3 pi r cubed. The next step is to take the derivative of this because we're working with rates in this problem. And so we're going to say V prime of t equals, we're moving the 3 forward, so 3 times 4/3 pi r cubed, and because this is not in terms of t, we're using r prime of t squared. Okay, so let's simplify that a little bit better and say V prime of t equals 4 pi r squared times r prime of t. And so after doing that, we're just going to fill in what we already know. So V prime of t we've already established is 25 cubic inches per second. So 25 equals 4 pi r, and in this case our r is 18 squared times r prime of t, which is our unknown. So now all we have to do is isolate for r prime of t. So r prime of t ends up equaling 25 over 18 squared times 4 is 1296 pi, and this would be in inches per second. And while this number doesn't really mean anything, to me, it is how fast the radius is increasing as our volume increases by 25 cubic inches per second. So if you put this into the calculator, it would be roughly 0.006 inches per second. And there you go. By breaking down the question into unknowns and givens, or knowns, we were able to easily find how fast the radius of the balloon is changing.